you, I did theorem 1, line from center perpendicular to a chord bisects the chord, together with the converse, okay, line from center to the midpoint of the chord bisects the chord, all right? Okay. Then I did theorem 2, angle at the center is 2 times angle at the circumference. Theorem 3, an angle subtended by the diameter is equal to 90 degrees, which we also call angle in a semicircle. Theorem 4, angles subtended by the same arc or chord on the same side of the chord are equal if they are on the circumference. And as a shortcut, we call that the angles in the same segment theorem. Right? So we did those. That's where we are.
So for the angles in the same segment, it is not also known as the butterfly or something.
Okay. Based on acceptable reasons there.
No, we don't write butterfly.
Yeah, it's just to help you to memorize, yes. Right. So I'm just going to repeat again the theorems that we have covered so far. Theorem 1. Line drawn from the center of the circle, okay, perpendicular to a chord bisects the chord. Okay? A line drawn passing through the midpoint of a chord is perpendicular to the chord. Okay? Then we have got theorem 2, angle at the center is 2 times angle at the circumference. Theorem 3, an angle subtended by the diameter on the circumference is equal to 90 degrees. Theorem 4, angle subtended by the same chord on the same side of the chord. If those angles are on the circumference, they will be equal. Okay, and we call them angles in the same segment. Right, so we are going to be using all that together with your knowledge from grade 8, 9, and 10 geometry. Okay, that's geometry of lines, geometry of straight lines, triangle geometry, and so on. All that has to be used. So let's do this question. Right, so here we need to find the values of those letters. Okay? Now, if you remember on the English alphabet, which letter starts first? Yeah, based on the letters that we are supposed to calculate. We have got T, and we have got, okay, that's T, this is Y, right? That's X, then we have got V here, we have got U, we have got Z, and we have got a W. So which one starts first?
T.
It will be T. Okay? So we need to determine the size of angle T. Okay? First, let's follow the alpha. Now, if you look at angle T, it's this angle. This is angle T. Which chord subtends angle T? It's called what? BC. Right? And does chord BC subtend another angle on the circumference? Which angle? If you say angle E, there are two angles there. If you say angle E, there are two angles. Okay? You need to be very specific. Which angle here? Which angle here is subtended by chord BC? It's angle U. This angle here. But we don't know the value of U. But angle U is subtended by chord BC, which means angle U is equal to angle T. So there's another one. Okay. And also, this angle here is also subtended by chord BC. So we have three angles that are subtended by the same chord. Can you do me a favor, Judah? I need to pay attention. Can you move that bed there? I need to see what you are doing. Okay? So we have three angles that are subtended by the same chord, which means those three angles are equal. Okay, so this is so simple. So I want to find T, so I'll say T is equal to, okay, well, I can just write it as angle T is equal to angle G, they are both equal to 40 degrees. And my reason is angles in the same segment. That's my reason. Okay? Based on the examination guidelines that I gave you here. Right? So if you look at right at the bottom, okay, from the bottom, if you count the number of rows from the bottom, 1, 2, 3, 4, 5, you go to the fifth one from the bottom. The fifth one, that's the reason I wrote it. Okay? I would suggest to you that you indicate that that's theorem 4. Because it's your worksheet and you're supposed to stick it inside your network. Okay? So I use theorem 4. Angles in the same segment. Okay? So I got T. So after T, which letter follows T on the English alphabet? U. Okay? So I'll end up saying angle T is equal to angle U. They are both equal to 40 degrees. The reason is the same. Angles in the same segment. Okay? So I now have my T, I've got my U. Okay? Looks nice, eh? So let's move on. After U, we have got V. So our V is right here at the center. It's this angle here. It is at the center. Okay? So V is going to be equal to what? Remember, for this question here, you cannot use theorem 1. Either it's theorem 2, 3, or 4. Okay? To find the value of V, you have to use theorem 2, 3, or 4. Yes?
So I think it's 40 degrees because it's also subtended by 9 degrees.
No. 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 Yes?
Sir, it's 2 times. It's half of angle E.
Yes, I know it's 2 times circumference.
Be very careful how you say it.
Half.
Okay? Angle of V is not half of it. It's 2 times. Theorem 2. Angle at the center is equal to 2 times the angle at the circumference. Okay? Angle at the center is 2 times the angle at the circumference. That's theorem 2. Both angles are subtended by the same chord, but angle V is at the center. Angle U is at the circumference. So angle V is 2 times angle U. So when you calculate V, you do V is equal to 2 times U, and then I'll say 2 times 40 degrees, and that will give me 80 degrees. Then I'll write my reason here, angle at center is equal to 2 times angle at circumference. Okay? Just to remind you where I'm getting this from. Right? Under circles, if you count from the top under circles to 1, 2, 3, 4, 5, 6. The 6th row under circles. So that's theorem 2. Indicate it on your on this document I gave you. Indicate it as theorem 2, and you need to do the same too. Okay? This section is not like the other topics. Okay? It's better for you to move in the same frequency with me. So that's theorem 2. Okay? So just to remind you, so here, based on how I taught you, this is theorem 4 and that's theorem 1, theorem 2. Alright? So we found the value of V. Then from V, so we have got W there. Right, that's the angle. We need to find the size of angle W. Okay? Now, which chord? Because when you're answering these questions, right, they will give you a diagram like this where you have to use all the theorems. Right? It's very important for you to identify the following whenever you're answering questions on geometry. Identify radii, identify diameters, identify chords, also the center. That's very important. Up to theorem 4, those 4 are very important. So when you see a question, ask yourself, is there a radius? Is there a diameter? Are there any chords? Okay? You must know whether a specific angle is subtended by a specific chord. Is there a center? Alright, so which angle subtends angle W? So which chord subtends angle W? It's what? AB. So we have got that. And does chord AB subtend another angle at the circumference? Which angle? Okay? You can call this one E1, that one E2 if you want. So we have got angle AEB, you can call it AEB, is going to be equal to W. The reason, theorem 4. So I'll say W is equal to, right? The way that I'm going to write it there, I'll write it as AEB is equal to 21 degrees. My reason, theorem 4, angles in the same segment. Okay? I hope you are following. I'm not doing my own thing. And geometry is not difficult. As long as I am your math teacher, geometry is not difficult. If it used to be difficult in grade 8 up to last year, that stopped there. It's not difficult anymore.
So,
Alright, yes.
may I just ask what is the average cost of the average cost of maths?
The average. Okay, I'm not sure. Well, I need to check the document.
Because I'm going to use the average for maths was always like 80.
Alright, so where is x? Let's identify where x is. Right, x is here. Right, this is x. Okay? Now, if you look at x, okay, do we know the size of angle y? No. We don't know the size of angle y. So this is our x here. Which chord subtends angle x?
AB.
What?
AB.
AB. Does chord AB subtend another angle on the circumference? Angle AEB. Okay? So, theorem 2. Angle at the center is 2 times angle at the circumference. Angle X is subtended by chord AB, but it's at the center. Angle AEB is subtended by chord AB, and it's at the circumference. Therefore, angle X is 2 times angle AEB. Okay? So allow me to write that on the next page. Okay, what I'm going to do is, let me take this diagram. All right. So what I said was angle X. Right. One thing that I have seen over the years is that geometry is not as difficult as what people want it to be. It starts in the head. The perception and what you hear from people. Right? In my class, geometry is an easy topic. So we have got that angle there. it is subtended by chord AB, and chord AB also subtends that angle. Angle AEB is at the circumference, angle X is at the center, so theorem 2. Okay? You see the way that I'm talking, my heartbeat is not increasing because I saw the diagram. I'm just using the theorem. Right? So angle X is equal to angle AEB, and both are, and what this means is, I'll say X is equal to 2 times AEB. What that means that 2 times 21 degrees, and this will give you 42 degrees. And my reason is angle X center is equal to 2 times angle X circumference.
So, is it fine if we don't put the whole working angles on one line? So, like,
Yeah,
in the example, what I tend to do is I say x equals 2, and
X equal to 42, right?
no, I'll just write x equals 2 AEB, and then I'll give the reason. Then underneath,
You write the answer.
then I'll do the working AEB.
It's okay.
Fine.
Yeah, it's okay.
But you'll get the same answer.
Yes, it's okay. It's okay. Alright. So X and then Y. Okay, we now need to find Y. Alright. To find Y, right, it will be better to identify a triangle and use the fact that the sum of angles in a triangle add up to what? Right. Fortunately, we know the size. We know the size of this whole angle. Okay. We know X. We know V. Remember. So this whole angle we know. X plus V we know. Okay. We know the size of X plus V. Am I right to say so? Because we found X, we found V. Right? And this angle here and that angle, that is Y and Z, they are going to be equal because A, okay, from this point up to there, that's a radius. And from there up to there, that's a radius. So that triangle is more like it's isosceles. Right? Please allow me to make this point, to call it point O. Okay, because that's the center. That will help me to name the triangle. But before I do anything, this is where I'm gonna start. Right? Because of this space here, I might have issue. But let me try to write it on top. So what I will say is AO is equal to OB. So OC. Alright? Why? Because they are radii of a circle. Okay? That's where I'm gonna start. Then I'm going to say, therefore, angle Y is equal to angle Z. And my reason will be angles opposite equal sides. Not isosceles triangle. Okay? That's not the acceptable reason. It's not an isosceles because you are not told that it's isosceles. Okay, so don't make an assumption. Okay, don't make an assumption. When you are giving a reason based on two sides that are equal and two angles that are equal, I know that in the lower grades, your teachers were telling that the reason is isosceles triangle. From now on, that should stop. It's not on the examination guidelines. Now, if you go to triangles, don't look at me. Go to the page that I gave you. If you look at the third row, it says the angles opposite the equal sides in an isosceles triangle are equal. But how do you write the reason? It's not isosceles triangle, it's angles opposite equal sides. Okay? If you don't follow what's here, when you write metric next year, you may disadvantage yourself with the marker. Okay? Marks based on the reasons that are here. These are the national reasons in South Africa that are acceptable when you write a geometry examination. It is wise for you to learn now how to write them. Okay? Forget about how you're writing grade 8, grade 9, and grade 10. That's gone now. You are starting a new page. That's why I'm giving you this. Right? In the school, I'm going to instruct the teachers to not accept isosceles triangle. Okay? We will accept angles opposite equal sides. Yes?
So, you know, in when they teach us how to deal with x and y and a, usually with x and y is that in 35 they teach you n and stuff. So,
Yeah, it's the same thing.
Am I right in saying the papers you use what you want?
No. Listen. When we write the metric pair, generally they use x, y for equations. But sometimes they have other letters. But the meaning is the same. The letters represent numbers.
So you have to use the same exact letter.
Yes.
So for
Listen, let's not complicate this.
no, I'm just
Right.
asking
You need to know that the letters represent numbers.
Yes, I know. For the nutrition study, how when we get this department papers, we're going to have to use X instead of N.
But they don't anything.
No, it's not like that. Are you aware that the total only had 4 A's in last year? We had 17. Alright, you see?
I'm just asking, sir, because they're using N instead of X. It's just a question.
No, it's an issue of letters.
I know what it all means. I know.
It is the teachers who decide to use the letter rather than the daylight. But the meaning is the same. Alright, now, okay, here I want you to be aware that for algebra it's different. For geometry, everyone must follow what I gave you here.
Yeah, I was just asking because someone from TDI said they have a trick, they use N, they can talk. I was just wondering.
I think they probably gave you wrong information, that person.
Really?
Yeah.
But that person.
Alright, let's carry on. Let's carry on. So I said angle y is equal to angle z. Are you following that? Now that's very interesting to have y being equal to z, because we know that in triangle A or C, right, I'm identifying the triangle that I'm going to use to determine y and z, right? In that triangle, if I add angle y plus angle z plus angle x plus angle v, I'll get 180 degrees, right? I have to give you a reason. Now check this. If you look at number 1 under triangle, you see the reasons that are there. You can write angle sum in a triangle, or you can write sum of angles in triangle. The second one is the one that I like, or you can write interior angles of a triangle. So Mr. Tuponda prefers to write it as this one here, sum of angles, in a what? In a triangle, like that. I hope you are following.
Yeah.
Right? I hope you are following. Right? Then let's substitute now. The good thing is, if I want to find y first, I can replace this z by y. Yes, because look here.
It's the same thing again.
Okay, look here. Do you see what I wrote here?
Yes. Yes.
Y is equal to what? To z.
Oh,
Which means which means where there is z, I can put y. Where there is y, I can put what? Z.
So why don't you just put the value where the line of
I'm gonna do that. But remember, what's the objective of the question? Yeah. I cannot find y until I eliminate this z. I know x, I know v. Because I want to calculate y. Do you know the value of z?
Okay.
Wait, answer my question. Do you know the value of z?
No.
Do you know the value of y?
No.
It means we end up having two unknowns.
Sir, vision can understand my why. But how are you just gonna take it out of the equation?
Because I want to solve for y. I'm using Z to find Y.
Why don't you just use Y to find Y?
This equation here.
Because Y is not.
Are you aware that? Okay, listen, Tando, I hope you can see that we don't know the value for Z.
Yes.
But because Y is equal to Z, we are going to use the fact that Y is equal to Z to find Y. If we find Y, we will have found Z, because the two are equal.
So this is so how you're going to take like the
Wait. Okay, so let's carry on. My next equation is Y plus. I know what X is. Don't worry, if I carry on, maybe you understand it better. What is our X equal to?
42.
It's what?
42.
It's 42. So I'll put it here. And what is V?
80.
V is 80. Right? So I'll put 8 here. That's equal to 180 degrees. Then we can use our knowledge of algebra. This becomes 2y plus 122 degrees. That's equal to 180. Then you take the 122 to the other side. So you end up getting 2y equal to 180 plus that. You get what? 58 degrees. Are you following there? Right? Then obviously you divide both sides by 2. Then you say therefore y will be equal to 29 degrees.
So that was my question. My question was like, how do you even see that?
My answer to you will be we have to use the fact that y is equal to z to get the y.
So you just choose it to Y.
Yes, because they are equal.
So instead of could you have carried it's in y plus y plus 42 plus 80. If you have put z there, y plus z.
Where?
See the green
Why?
if you say y plus z in brackets, you could have said the reasoning is like saying the reasoning also is because the angles are equal, so you can say.
You already wrote that.
No, there's no need for me to go as far as putting y plus z inside brackets because already I proved that these two are equal here. Right? And I also wrote the reason why they are equal, and then when I use the effect that the interior angle of the triangle end up to 180, I gave a reason. Let's not complicate. Okay, let's not complicate it. Let's not complicate it. We are using the fact that y is equal to z. Okay? We are using the fact that y is equal to z. And this is the mathematical approach, where you use your knowledge of algebra to find y first. Or I could have calculated z first, but I'm going to follow the English alphabet, so I started with what? With calculating y first.
So is there no method two for finding Y?
You must go home, sit down, figure out method 2. Right? Then z is equal to 1.
Then you work it out the
Now,
same way.
here I can write my reason as proved above. Okay, but I'm just going to write, for interest sake, I'll write this is equal to 29 degrees. Don't forget that this will be in degrees. So my reason here will be angles opposite equal side. Okay. The technique that I used here, this technique here, is very important. There are some questions in geometry where you have to do what I did there, to replace a variable with another variable if they are equal. Okay? Any question? You don't have a question? All right.